Normal cells in the human body grow, divide, and die in a controlled and orderly manner. Cells in most parts of the body divide only to replace worn-out or dying cells and to repair injuries. Cell division is orchestrated by the cell's DNA and involves dividing all the cellular components to create two new cells. DNA even tells some cells when it is time to die and be replaced by new cells. Cancer develops when cells grow out of control due to an unrepairable damage to the cell's DNA. This damage is called a mutation. The DNA mutation can be a single base of the genetic code or a larger sequence of the DNA. The DNA mutation may be an entire gene or a section of a chromosome. Some mutations are inherited, but most mutations result from exposure to substances in the environment called carcinogens. A carcinogen is any substance which promotes cancer. There are hundreds of carcinogens, and they include radiation, some viruses, and many natural or man-made chemicals. It is estimated that 75% of all cancers are the result of exposure to environmental carcinogens. Mutations of the cell's DNA lead to abnormal and rapid cell division. Usually, the body's immune system is able to recognize these abnormal cells and produces antibodies to stop the atypical cells. It is thought that cancer cells are continually being created, but are being eliminated by the immune system before they form a tumor or spread throughout the body. The body's immune response may not always be sufficient to control the growth of cancer cells. When the abnormal cells have enough mutations, they start dividing uncontrollably, which leads to the formation of a tumor. The cells of the tumor continue to divide much more rapidly and invade nearby tissues, robbing them of nutrients and oxygen. In most cases, the cause of cancer is unknown. The risks of developing most cancers can be reduced by limiting exposures to potential carcinogens. These may include tobacco use, alcohol use, unhealthy diet, lack of physical activity, or exposure to the sun. Cancers grow at different rates and could respond to treatments if found in the early stages of growth.